Hello, everyone, and welcome back. Today, we're going to be talking about systems of equations where we have one linear and one circle. So, there's three possible outcomes. If we have a line and a circle, we might have no solutions, like on the left, where the circle and the line do not touch ever. We might have one solution, like in the middle, where the circle and the line touch exactly once. And then we might have two solutions, like on the right, where the circle and the line touch twice. Now, how can we solve the system? So, the main way we would solve a system of equations where we have a circle and a line is by using substitution, right? Graphing could also be another technique, although graphing can be a bit more challenging, or also depending on the line and the circle, it might not necessarily be completely accurate, right? We might have to, give kind of an estimated answer in some cases with graphing. And so I would say the best way to get the exact answer is to use substitution. Elimination also is probably not really going to be very useful here because we would need to be able to eliminate one of the variables. And because we have x and x squared and then y and y squared, it's not going to be very simple to eliminate a variable. And so substitution is the way to go here. Okay, so let's do that. What I'm first going to do is I am going to manipulate this first equation, the linear equation, to get y is equal to 1 minus x by subtracting x from both sides. And then I'm going to plug that into the circle. And this is what we are going to commonly do. We're going to manipulate the linear equation rather than the circle, and then use that manipulation in the circle. Okay, so then we have x squared plus y squared equals 9. So I'm going to substitute y equals 1 minus x into that equation. So wherever I see y, I'm going to replace it with 1 minus x. So then I have x squared plus 1 minus x squared is equal to 9. Then I'm going to expand my brackets, the 1 minus x squared. So that's going to be x squared plus 1 plus x squared minus 2x is equal to 9. And that is going to be 2x squared minus 2x plus 1 is equal to 9. So now we can tell that we do have a quadratic here. And so we can take whatever steps we need to take in order to solve this quadratic. So I'm going to subtract 8 from both sides. We're going to get everything on one side, and then we'll discuss how to solve it. So we're going to have 2x squared minus 2x minus 8 is equal to 0. Now, in this case, I'm noticing right away that if we divide everything by 2, or if we just factor a 2 out, we can make the equation more simple. So let's do that. We're going to get x squared minus x minus 4 is equal to 0. And this is a pretty relatively simple equation, so we might actually be able to figure it out without using the quadratic formula. So we need to find two numbers that multiply to negative 4 and add to negative 1. So let's see if we can do that. It could be 1 and negative 4, could be negative 1 and 4, or it could be 2 and negative 2. Now, actually, none of those, if we add them, would give us negative 1. So for that reason, I'm going to conclude that we aren't able to factor this. At least not easily by inspection, and so therefore I will go to using the quadratic formula. And that's a key thing as well whenever you are trying to factor a quadratic. If you're not able to factor it fairly quickly, I would just honestly turn to the quadratic formula, because sometimes it's not possible, or sometimes the amount of time it will take you to figure out how to factor it is a lot longer than it would have just taken to use the quadratic formula. So we're going to scratch this since we didn't find the answer right away and use the quadratic formula. So we have a is equal to 1, right? Because a is the coefficient of x squared. B is equal to negative 1, because when we have negative x, that's the same as negative 1 being the coefficient for x. And then c, which is our constant, is just going to be negative 4. And I'm going to plug this into our quadratic formula. So x is equal to negative b, so negative negative 1, plus or minus b squared, minus 4ac, all over 2a. So all over 2 times 1. That's going to be 1 plus or minus the square root of 17 over 2. Okay, so that's why we weren't able to factor it, right? Because 17, even though there are two solutions here in this case, right? It's 1 plus root 17 over 2 and 1 minus root 17 over 2, even though those are the solutions, these are irrational solutions. We weren't going to be able to figure it out by just trying to factor it by inspecting it, by guess and check. That wasn't going to work for us. Okay, so now what we need to do in order to find the y values is we need to plug in each of these x values to find the respective y value for this. Okay, so here we have, I'm going to be using the first equation just because I think that would be easier, but you can use whichever equation you would prefer. So the first equation was that x plus y is equal to 1, or y is equal to 1 minus x. So therefore, when for the x is equal to 1 plus plus root 17, we'll do plus first. Y would be equal to 1 minus x, right? So 1 minus this, 1 plus root 17 over 2. And I will simplify that to make it a little bit nicer. I'm going to put 2 over 2 here instead of 1 because 2 over 2 is the same thing as 1. So therefore, y equals, 2 minus 1 plus root 17 over 2, which is equal to 1 plus root 17 over 2. Okay, so there we go. There we have it. Oh, and I made a small mistake here. So this negative, when we subtract, it has to go to both of these, and I still put plus root 17. It should have been minus root 17. I knew there was some mistake I made there. Okay, so there we go. So therefore, one of the solutions is going to be 1 plus root 17 over 2, comma 1 minus root 17 over 2. So that's one of our solutions here. Okay, now what about the other solution? What if x is equal to 1 minus root 17 over 2? Let's find that solution. Okay, so if x is equal to 1 minus root 17 over 2, y is equal to 1 minus all that, so 2 over 2 minus 1 minus root 17 over 2, which is going to be equal to, let's see, 2 minus 1 is still 1, and then plus root 17 over 2. And so the other solution is 1 minus root 17 over 2, comma 1 plus root 17 over 2. And those are our solutions. So I'm going to kind of box in here our solutions to be clear. Oh, oops. There we go. These are our solutions. So in this case, there were two irrational solutions to that first system of equations there. Okay, let's try another example for part B. I know I kind of went into part B's space, but that's all right. We can just erase this and start again. Okay. So for part B, we have y is equal to negative x plus 3. And then for our circle, we have x plus 2 squared plus y plus 1 squared is equal to 10. So I'm going to sub in the y equals negative x plus 3 into the circle equation. So let's do that. So then we're going to have x plus 2 squared plus negative x plus 3 plus 1 squared is equal to 10. Then I'm going to simplify that second bracket there and say, well, this is really just 4 minus x squared. And then this first one can just stay as is. And the 10 can stay as is for now as well. And we're going to end up with another quadratic. So let's see what we get. Okay, so for this first bracket expansion, the x plus 2 squared, we're going to get x squared plus 4x plus 4. For the second bracket expansion, we'll get plus 16 plus x squared minus 8x is equal to 10. Then I'm going to collect like terms on the left. So x squared plus x squared gives me 2x squared. What else? We have 4x minus 8x is going to give me negative 4x. And 4 plus 16 is going to be 20. Next, I'm going to subtract 10 from both sides to get 2x squared minus 4x plus 10 is equal to 0. Then I'm going to divide both sides by 2 to get x squared minus 2x plus 5 is equal to 0. And once again, we have a pretty simple equation here, so I am going to see if we can factor this quickly. If it turns out we can't factor this quickly, I'm just going to scrap that and we'll move to the quadratic formula. So let's do that. Can we find pretty quickly two things that multiply to 5 and add to negative 2? Well, the only thing that would multiply to 5 would be either negative 1 times negative 5 or 1 times 5, and neither of these add up to 2 and or add up to negative 2, so we're going to scrap that and just go in with the quadratic formula, because that likely means that either the solutions are irrational like they were the last time, or it's also possible, keep in mind, that there just are no solutions as well, right? Now, if there were one solution, then we actually would be able to factor it pretty easily, so I do not think that's the case. Okay, so let's plug that in the quadratic formula. We have a is equal to 1, b is equal to negative 2, and c is equal to 5. So x is equal to negative b, or in this case, negative 2, plus or minus the square root of b squared, so negative 2 squared minus 4ac all over 2a, like that. And that's going to be 2 plus or minus the square root of 4 minus 20 all over 2, which is going to be equal to 2 plus or minus the square root of negative 16 over 2. And at this point, you might notice that we have a negative in our square root, and that means there are no real solutions. Now, if we want to get into the complex number system and write down the complex solutions, that's totally fine because there are two complex solutions here. However, there are no real solutions, and so this would fit into that first category, right? This would fit into this first category of no real solutions. And whereas the first one, part A, would fit into the category of two real solutions. Even though they were irrational, they were still real solutions. So there's the differentiation there. As always, feel free to put any questions you have about any of that in the comments below, and we'll see you for the next one.